Welcome back to my YouTube channel. In this video we are going to talk about valley winds. We will be focusing on the Alps. First and foremost, you have to focus on the macro, on the global scale. So for the Alps, I would look at the system in general, how the whole Alps work. So that I call the macro. The local is the area that will influence your takeoff. In this case, we're gonna focus on Chabre, this triangle right here. It's basically roughly from Sisteron to Gap to Grenoble, and the flats on the west of Chabre. Micro is what you are actually looking and forecasting for. That's your takeoff. That's where you're gonna focus on. To understand valley winds, we have to cover the basics. I'm sure most of you know this. The reason valley winds are created is that the sun comes around in the morning, it heats the mountaintops first, the air rises and pulls the wind towards it. Land always warms up faster than the seas. Mountains warm up faster than the flats around. The reason mountains warm up faster is because the peaks are higher and the peaks get the sunlight first. Plus, the angle and the shape of the mountain is better situated towards the sun rays. That is what basically creates the valley breeze and the mountain breeze, or the katabatic and anabatic wind. In the morning, mountaintops warm up, the air is being pulled towards them. In the evening, the mountains cool down first, surrounding flats. Any kind of water body will cool down slower than the mountaintops, so the air will be pulled towards there. Let's have a look at an example. On the left side here, we have Taiwan, which is an island. In the middle of the island, we have almost 4,000 meters high mountains, a lot of 2,000 to 3,000 meter mountains, and surrounding the island is the ocean. Alps is quite similar. We have the Alps, which is the highest peaks in the region. To the north and west of Alps is mostly flat. To the south we have some sea. To the east it gets more flat as well. What happens in the morning is when sun comes around, it heats up the mountaintops. The air rises in the center of the Alps, in the massif of the mountains, and pulls the surrounding air towards it. Here in the red I have indicated the hot air area, or the lower pressure, which is also called the heat load. It should not be confused with high-low pressures as a global system. It does act in the same way. The low pressure pulls everything towards it from the high pressure. Air always will move from the colder air to hotter area, or from the high pressure to low pressure. This happens on every given day without major meteor systems influencing the result of it. The whole video here is only talking about valley winds, ignoring the meteor system. So we will focus only on the valley winds, on the local systems. If we're gonna talk about Chabre, the local system here is this orange area. It goes all the way from Annecy down to Nice, and west of the France will affect our area. And zoom in more, here on the right you can see the orange rectangle. That's where the area is on the map in the Alps. This area is what we're gonna focus on. On the east of Chabre we have the Alps, indicated in red. So they will heat up first. The mountain ranges, they are higher mountains, taller mountains than anything around Chabre, or west of Chabre, or south of Chabre. The blue area is the Mediterranean Sea, and the orangey area is the flats of France. These three systems influence the weather conditions locally in Chabre. On top of that, we have natural blocks. South of Chabre we have three main mountain ranges that blocks the southerly wind. West of Chabre we have multiple different mountain ranges that is about the same altitude as the takeoff on Chabre, and that blocks the westerly. Eventually, the south or the west, depending on the day, will take over and will be able to move all the way to Chabre. But because of these blocks, the southerly winds or the westerly winds can't get in early in the day. To me, the best way to think of valley wind is the same as rivers, the same as water. They always will choose the path of least resistance. For Chabre to have valley flow, these are the main valleys, the main openings in the mountains. This is where the wind will flow the most easy. So locally that creates a southeast wind first before the other systems can move in. On the right side you can see I have indicated the local southeast system. That's how the valley flow will move around Chabre on any given day without major meteor systems changing that. The westerly system is initially blocked by the mountain ranges west of Chabre. As the Alps on the east heats up, they pull more and more air towards them, and the westerly system starts moving towards the southerly system. Eventually it will arrive at the takeoff area of Chabre and take over. In the middle of the summer, around 1 o'clock to 3 o'clock in the afternoon, depends on the day and depends on so many different things, roughly between noon to 3, you can expect to have the west wind move in and you won't be able to take off anymore. It's flyable if you're in the air, but on takeoff that will be crosswind and you won't be able to take off easily. These systems will push each other on every given day. The southeast is the first system. It stops around the red circle on the left picture, which is the mountain La Longagne. It looks like a boomerang. It's end of the valley and it's the tallest thing nearby, and it blocks the southeast. That's roughly where it stops. On the left side there's the west system. You can see the blue arrows. I've indicated the local valley flows on the west side of the Chabre, northwest side. They are blocked just on the edge of the southeast system. Again, because it's just a physical block, they're tall enough, they're perpendicular to the westerly flow, and they will block the west for a while till the west gets strong enough to push farther towards gap, towards the Alps. On the right side here, I have indicated the three systems: the southeast system, west system, and the north system. The north system comes from Grenoble all the way up north. There is the first big opening for the west to come in, and it turns into north locally towards the Chabre area. Here on the left side you can also see a thermal map of the area, and you can see where people have flown the most. Where the systems meet is where convergence zones are created, and this is clearly indicated on the map on the left here. On the right side here I also have shown with orange lines where the local convergences are created based on the large systems and on the local microsystems that are created in between each tiny valleys. You can also see how the valley winds are going around the mountains. They're just being blocked by the height of the mountain and they have no choice but to go up, and that creates the convergence zones, makes for a more convenient thermaling. You can glide farther, you can fly longer straight. Convergence zone will keep you up. On top of that, if you ever flown in this area, you often will see cloud streets around these orange lines. If you look a bit closer on the left side, zoomed into the Chabre, even though we have heating mostly from the south side, and dominantly it will be from the south as the sun comes around, as the sun gets high enough middle of summer, it will also heat the northerly part of it. It's not heating only the south side. At the micro level, you'll have north wind on the north side of Chabre. But if you go to Orpierre, on the opposite side of the valley, that will be south-southeast wind. This is something to consider. There will be differences in wind. That's why often when you land somewhere middle of the mountain ranges, all of a sudden you have different wind direction. Wind goes from the lowest point to the highest because the highest heats up first and they have lower pressure locally than the valley floor. Wind always goes from the high pressure to the low pressure. Because of this, early in the day we have southeast in Chabre that changes to south, south-southwest, southwest-west throughout the day. As the Alps increase in the heating, they will start pulling more and more wind towards the east. Here's an example of a flight that I've done from Chabre. On this specific flight, it was really well indicated the winds as I progressed throughout the flight. Initially, when I took off, I had really strong east wind down low. As I got higher, that wind turned to southeast. As I moved more west from Chabre's takeoffs, I got more and more westerly winds. Here you can see that it is west-southwest wind direction. As I move even more west, it became fully west wind. As I progressed in my flying and went more north, that wind became a little bit more southwest and later on even more west. Moving even more north, that westerly wind started turning into the northwesterly wind, clearly shown in this track log. I will leave the track log in the description so you can have a look at it yourself. And this helps you to plan the flights, knowing the systems, how they interact with each other. You can use that. This is the reason why from Chabre it's really nice to go west first, use the southeasterly winds. As the west gets stronger, you come back towards the Chabre area to Beaumont Mountain and then move on northish as the westerly, southwesterly winds help you go up. Once you encounter the northwesterly winds, come back to Chabre, again flying tailwind. And here's a zoomed in version of the same area. You can see how the winds changes going towards the northwest. It was west slight with a slight component of the north. Coming back, it was already full northwest wind. And this is also why I created the Chabre challenge the way I did. That's why you go west first, come back, go north. As the system heats up, the westerlies will come in. Use the westerly winds to go all the way east to shore. From the morning till the late day, you're using the local flows to help you move forward with easier flying. You have your southeast in the morning, westerlies come in, they first start southwest, use the southwest to go north. As they become stronger west, you start moving east. I created this Chabre challenge with turn points on each trigger point. On top of that, Chabre challenge is created based on convergence zones locally and the local systems. And here with the orange I have indicated the local convergence zones that helps you to do the same flight. In this animation you can see where the three systems usually meet. Of course they go a bit here or there, it's never exactly because it depends on the day, on so many different things. What I'm trying to show you, the more you understand the macro systems and how they will affect your local area and your micro area, the more you can use these systems to your advantage to fly farther, faster, easier, and more consistently. To get your Chabre challenge, you just have to sign up to email list and you're gonna get an email with a free 24 pages full description of the challenge, how to fly it, what's the best routes to do, where's the trigger points, where's the hazards, to help you do your first 100-kilometer flight from Chabre in France.